this workshop is really going to be to cover some of the high-level concepts for Drosera. It's really acting as like a starting point for people, because we may have people that know about Drosera, some people who don't know about it, some people know what a trap is, some that don't. So I'm going to be able to provide a high-level overview for all of that. And I'll start off by just talking about what Drosera is. So at a high level, Drosera is an EVM protocol. This is kind of a very unique protocol that hasn't really been done before. And we are kind of showing off this way that you can actually build infrastructure and automation using just smart contracts as a primitive. And we specifically have made a new smart contract primitive called a trap contract. That's really the main focus that you should think about when you think about Drosera. You think about traps, this idea of a smart contract that can run off-chain. It's a new way to build on Ethereum that allows you to build capital efficient, verifiable, testable off-chain infrastructure with only Solidity, right? So only the language that is effectively used for protocols like, Uniswap, Aave, Bouncer, some of the big protocols you already know about. And traps are these other type of smart contracts that can be ran off-chain by Drosera nodes. And this allows us to effectively have off-chain execution with only Solidity. That means there's a whole host of new types of functionality that are available. You can use Drosera for risk management. You can use Drosera for security. You can use Drosera for trading. You can use Drosera for games. It allows for you to have infra that's just Solidity. So that's the main thing that you should understand. Okay, so yeah, this is the main site. We just actually put this together. We haven't put together an announcement for it, but check it out. It is pretty cool. So before I kind of dive further into core concepts and really start getting into this workshop to help you guys understand what are the core things to think about, I want to just provide some other information here. If you don't know other resources, ways to learn about Drosera, you can go to the dev docs, dev.drosera.io, and you can see tons of information about what a trap is, how does it work, and how do you use it. There's also X articles as well. We have a lot of X articles. So there's a lot of reading material out here for you guys to look through and understand what we're all about. So let's just kind of dive into it. Somebody asked, what is Solidity? Solidity is the language that is used to create smart contracts, loans, lending. That's what Solidity is used for. So let's talk about the three components here. When you're thinking about Drosera, you should think about these three pieces. There's going to be a trap Solidity file, which is this guy here. Usually it uses the .sol extension at the end of the name. It'd be like, Trap.sol or, faucet Trap.sol. Really, this is just where you're going to have your Solidity logic, is this Solidity file. And then a Drosera.toml file, and then the Drosera operator. Those are the three main things to understand. Obviously, this is all for Ethereum as well. So when you're thinking about Drosera, smart contracts, Ethereum, and the fact that Drosera has like these node operators that can actually run these trap contracts. You see this diagram is showing a trap contract inside of the operator. That is effectively what is happening when you have a Drosera node that is running your trap, right? It's running the execution of that trap within this node. So let's talk about each of these pieces individually, starting with the trap solidity file. The main thing that you should understand with the trap solidity file is that that's like the logic for your trap. That's the if else, and grab this information, do something with it. The big piece to take away here is that it has the ability to collect information from Ethereum. So it's like this smart contract that can pull all sorts of different data in different state from other protocols, other smart contracts on Ethereum. You can think of this as like this smart contract that is monitoring the space. It's monitoring Ethereum, the state of Ethereum, and then doing something with that. We'll get to that. What exactly the trap is doing with all the information as we kind of get through this workshop. But this is the main first thing to understand. A trap is collecting that information in order to do something with it. This is an important primitive to understand for infrastructure in general. Infrastructure is just, some computer that is grabbing some data and then doing something with it, right? And that's what we've done, except it's only with smart contracts. The Drosera.toml file is the second file for you to understand that lives on your computer when you're building traps. Showing here, the main thing that you're going to be working with if you're building traps is on your computer, you're going to have that solidity file and you're going to have this toml file. This Drosera.toml file is like a configuration file for your trap. You can see in this diagram, you have this Trap.sol pointing to these like configuration fields inside of a toml. So when you're building this stuff, you just need to make sure you have those two files. The rest of these workshops, you can see that we've already kind of done some of this stuff for you. In this like first workshop after the one that will run tomorrow, you can see this as a trap.solidity file, as well as down here at the bottom, there's a Drosera.toml file. Those are important for basically being able to actually like go and deploy these traps. So that is the main thing to understand there. So this is all just for configuration. It's for setting particular fields of saying like, this is the trap I'm going to deploy. This is how many operators I want to have on my trap, and a few other things. Then the third core piece is the Drosera operator. This is the part where I need to kind of explain that Drosera is not an L1. It is not an L2. We have kind of seen some of these questions from people saying, is it an L1? Is it an L2? What actually is it? It's kind of like the secret third thing. It's not exactly an L1. It's not exactly an L2. But the best way to understand it is that there is effectively nodes that anybody can spin up, and these nodes can run those trap contracts. They can run those trap contracts by being able to opt in, and when they're opting in, they effectively can run this trap for you. That means that you yourself could spin up your own operator and run it locally, or run it in a VPS and have that operator run your trap, or you could have other people run your trap for you. The main thing to understand is that when you go and deploy that trap and the operator is running it, you can think of that trap like living in that operator that is running your trap. These are kind of very special smart contracts. Normally, smart contracts live on chain, right? When you're interacting with Ethereum, you're, executing a transaction against a contract that is on Ethereum. With traps, they're kind of like off-chain smart contracts. They live outside of Ethereum, although they're connected to Ethereum. So they're really kind of living within this operator network, these operators that are running your trap. You can see here the collect function I was talking about before for a trap, how it's grabbing information from Ethereum and then doing something with it. So it's grabbing block by block information about Ethereum and passing it into the second piece called should respond. That is kind of like a function that determines some type of issue on chain. It may decide, based off of what's written in the trap, I need to pause the protocol because of this data I collected. It's seemingly showing something bad has happened. So that would be an example of a trap that is being used specifically for security, something that is doing analysis over all sorts of different state data, and it's doing it over multiple blocks, right? So these are smart contracts that can do time series analysis. They can look at information from blocks 1 to 10 and make a determination of, based off of all of this data, do I need to do something? Okay, so those are the three pieces. In conclusion, the main things you should take away from this stuff here is that a Drosera.toml configures a trap. A trap collects data every block, and an operator determines whether it should respond on chain based on that collected data. If you understand these three pieces, you're already looking pretty good to understand how Drosera works or how you may build with Drosera. Okay. The next piece is where we start to get into some of the finer grained details, but hopefully this will also help you understand a bit of like how do traps actually work. Okay. So in this diagram, we've got a lot going on, but it's actually not that complex. We have the blockchain at the top right here, where you're showing block by block new blocks that are being created, right? This would be like Ethereum. Ethereum is creating new blocks, and the trap is right below. The trap is collecting data from the current EVM state. It does that as new blocks come in. So you can see as new blocks come in, like block 300 here, that trap will eventually collect data from that state of Ethereum. You can also see that the trap has a state that it's collected in the past, right? It's collected block 294, 295, 296, all the way up until 299. And based off of the data that it's collected, it will pass that collected data into the should respond function, right? There's only two functions that the Drosera trap has. It is collect and should respond, right? It's these two pieces. Those are the main things to understand. It's collecting, and then it's asking the operator, should I respond based off of this data? Okay. And the specific situation where it should take an action on chain would be if should respond is true. So I may make a trap that's saying, actually, should respond should always be true, and it's just constantly triggering, right? You could do something like that. You could also have a trap that says, I only want should respond to be equal to true if the block number is sometime in the future, like block 300. You know, if block 300 gets produced by Ethereum, this trap will say, should respond is true, take action. Maybe that action being taken place is trading some stable coins. Maybe it's pausing a protocol. It can be any on-chain action. So this makes traps very versatile. It makes them very configurable, very flexible. But the best thing to understand here is we're collecting information, and then we're deciding what action should we take based off that information. This is another example that talks about the collection process a little bit more in depth. So far, what I've been talking about here has been, well, you're collecting some state, you know, every block, any state, but what actually could that state be? In this diagram, we're showing you can grab any type of state from other smart contracts. Those smart contracts may be protocol A, protocol B, protocol C, protocol D. In this example, I'm just showing that you can grab any of the state on those other smart contracts on Ethereum. This means that Drosera traps can have aggregate what's the on a bridge, what is this price that an oracle has put on chain, how much liquidity is in a Uniswap pool, right? So any data that lives on chain, a trap can go and query for that and then collect and do something with that information. This last image here, it provides kind of like a whole picture for what are all the components. It may seem a little overwhelming, but based off of the three things I described earlier, the three core concepts, operators, traps, Drosera.toml, this should help you kind of understand what this all looks like in practice. So at the top here, you have your trap contract. Below are the operators that are running it. And you can see this trap contract is pulling information from Dogcoin contract, total supply. You can see it's grabbing information from a DEX contract, Dogcat pool, Dog USDC pool. And you can see it's also grabbing information from a bridge contract, right? So this is like Dog TVL, pause status, multi-sig addresses. And this trap is basically being ran by these operators and collating all of that information in order to determine this last piece right here. Basically showing, should we respond? Should we hit this emergency function based off of this data that we pulled? Maybe our trap is set up to trigger the emergency function if total supply increases by 200%. Like maybe that should never happen. Then you can set up this trap to do so. Before I go on further, do I have any questions in the chat from anybody? Let me look through here if there is anything in particular. I just see a lot of boba on top. Boba on top. Okay, cool. I'm on top. One of the questions is, if I deploy a public trap in the current testnet without opting in with my operator, will the special protocol level operators find my trap and opt in? Right now, the best thing to do is to do testing with your trap by spinning up your own operator. And doing that, you could do that locally and do some testing by having your operator opt in and then running it for a while, doing some kind of experimentation there. You could also run your operator in a VPS and have it run over time. And you can update your trap and experiment with it more there. It's a lot easier to do that given that we have like 20,000 traps. This is probably the best way to go forward. But obviously you can also reach out and honestly even reach out to the community if you want somebody to run your trap for you. You could try to say, hey, I want somebody to run my trap. I'll whitelist you if you opt in and run it. That would also be a really cool experiment. Another good question. It looks like Drosera can be used for smart contract security. Yeah, this is one of the core pillars for Drosera, which has been a focus on security. Mainly because, security is probably one of the biggest things to focus on in Ethereum today, in crypto generally speaking. So traps can be used as kind of these little guardians, these little monitoring systems that can look at information on chain to determine if something bad is happening. That might be, oh, I just saw that the bridge's TVL just dropped by 90% in a single block. I want to take my assets out, or I want to move something around. You can use it for security, and anybody can use it for security. So you could use it for just yourself. Other protocols could use it. DAOs could use it for security reasons. There's a lot of security use cases that we've mentioned on our main site as well. If you go to case studies, you can see here about the Nomad hack. and the Euler hack as well. Uh, Another good question is, how does Drosera handle the challenge of balancing rapid automated threat response, such as pausing contracts, with minimizing false positives? Well, the really nice part about Drosera is that it's just these nodes that are executing your smart contracts that you've written, your trap, right? So they're just executing your trap, and then they're grabbing information on chain. Because we have all this data being brought from on chain, all this information is verifiable. So we can actually verify that when a claim was made on chain, some incident response, we can verify that that was actually a correct claim, mathematically correct. This is mainly because of, well, the way that smart contracts are set up, the fact that they are verifiable, but also because we use some ZK as well in order to do proof of execution. So this minimizes false positives, and it allows for us to have really rapid response because Solidity already has a lot of these like proof-based systems built into it for verifying all of the state data. Can you explain also how Drosera games and trading works with security? Um, so we did make a chess game, if other people don't know. Uh, we made uh, this this app where people can actually go and play chess, and it uses a trap under the hood. This is another example of our technology being able to be used for infrastructure. So this is all just being run by a single trap that is collecting data on chain. It's collecting players' moves, right? It's using that collect function that I was showing before to pull in data from a chess contract on chain. So it's doing the collection to see, are these valid moves? And then if they are valid moves, then it will perform an automated action to verify that that player's move was correct, and it allows the game to continue to move on. So it's just another way to show how smart contracts as infrastructure is really powerful. Okay. Um, Another good question is, how many blocks can pass from the block triggering should respond till the actual response transaction? As far as I understand, some time may pass to reach consensus between the operators, and then one of the operators will create the response transaction, and the transaction may not have enough gas for that certain moment, stick for a while. Is such a situation possible? So that usually won't be the case, having like a stuck transaction. Normally, uh, what will happen is operators will come to consensus very, very quickly, and then the operators will attempt to push the consensus information on chain in order to have an automated response. And so let's say if you have like 10 operators, one of those operators will certainly have their transaction executed and included. Um, Also, these operators are going to have gas on them, so they're not going to be in a situation where they're going to have like a stuck transaction. We have software built in to the operator to actually recognize if there is a stuck transaction, and it will fix itself to unstick the transaction without any manual intervention. Okay. Um, does anybody have any particular questions on um, understanding the Drosera.toml and the Solidity piece? Um, those are the main pieces you're really going to be um, playing with as a part of the workshops. Um, you can see over here on the left, there's workshops 1, 2, and 3, and they have Solidity files in there, instructions. If you haven't seen what Solidity looks like, this is what it looks like. the best thing to understand here is that when you are like running these workshop exercises, as we kick these off like tomorrow and the next day, you'll want to check out this repo called Drosera Workshops. I'll make sure to share this one out, blast it out so that everybody knows where to go. But you'll want to go to this repo and you'll want to check it out, and you'll want to kind of like run the instructions and the setup here for this workshop. Um, okay. Are there any other particular questions from anybody? I think that this kind of covers everything at a high level. The conclusion here is if you want to start building the traps, you need to first write a trap solidity file, create a Drosera.toml file, and then run a Drosera operator. Luckily, we've already built these things for you in these workshops. You simply need to install the Drosera CLI, which I've put here and exists in the dev docs and some other places in this workshop. So that really should get you started. I've also put some resources here below if anybody hasn't seen. There is a Drosera YouTube channel, the dev docs, some examples as well, showing how traps can be used for security and other reasons. And we also have this example of a kind of like a chat GPT bot that has collected a lot of our data from our docs. So you can ask questions to this chatbot. And since it's already scraped our docs, it should be able to give you a good idea of what's going on or help you with any of your questions if you aren't getting any questions answered in the Discord. Okay. I think other than the stuff, the next thing to point out is that the plan for tomorrow is that we'll do another workshop where we look at workshop 1. This was just the intro workshop, so we'll do workshop 1 next, where we're gonna just like actually walk through how do you do this, how do you deploy a trap, and that's really kind of the main focus, is trying to make this process as easy for you guys as possible, and just starting there. Can you guys deploy a trap, right? And if you can go from understanding these core concepts to deploying a trap, then you should be able to participate in some of our challenges that we'll be doing over the next couple weeks. Some of these challenges will be more in depth, like can you detect an exploit, and then we'll have a leaderboard to show off who is trapping these mock exploits first. And that would be really fun for the community to participate in. But this is a good training ground where you guys can ask a lot of questions before we kick off those challenges. So we'll be in the Discord to try to help you guys out and answer more questions. I was going to see if there's anything else to add. It's really great to see that we have almost 200 people here. Thank you guys for showing up. I'm glad that we were able to do this, and hopefully we'll just continue to kick these things off every day and see you guys show up. And also, you guys should know that all of these like workshops are going to be recorded and put on YouTube, so you can always go back to these and rewatch to understand step by step what something is, or understand some type of explanation. But I think that that's kind of everything that we wanted to cover. I think we have some of the team also in the chat as well. I was going to see if any of the team wanted to come up to speak on anything else that we haven't covered yet. I was going to bring John up just to talk generally about any of this stuff.
Hello. So I'm just answering some questions in here. I won't type this one out, but somebody asked about do you have to create the JSON file using Foundry Forge, or can you use Hardhat or Remix? We, as a team, prefer using Foundry. We think and believe it's a better testing framework and just overall framework for interacting with Solidity. So we would say if you aren't familiar with Foundry, definitely get yourself familiar, only because it will make your life a million times easier when you try to debug anything. Because if anybody's used Hardhat in here, they know that when you start testing things and something goes wrong, you don't necessarily know what's happening because you can't see traces in your transactions. And so at first, if you're not familiar with Solidity, it may be slightly difficult, but if you're going to be using Solidity for your smart contracts, use it for your testing and use it for your scripts because it will make your life that much easier. So we definitely recommend using Foundry. You don't necessarily have to. You could compile all your contracts with Hardhat, but long term, we would suggest taking like a small deep dive into Foundry.
Yeah. Yeah, Foundry is also just, I mean, it's a really good tool. Like you'll thank yourself for using it. I used Hardhat before I used Foundry or Forge. I'm really happy that I moved over because it just makes the process for testing smart contracts so much more clean and easier than to kind of like work with kind of JavaScript, TypeScript, Hardhat. It allows you to kind of like context switch a little bit less between programming languages. Everything is just in Solidity, which is kind of like a main sticking point for why we made traps in Solidity as well. A protocol is or a person is already familiar with smart contracts, or at least has like already built them out. You don't need to kind of change to a different language. You just stay within a smart contract land and just writing Solidity.
Yeah, much easier long term, but I can understand because again, I was coming from Ganache and Hardhat, and it is weird at first not writing things in JavaScript. But once you start doing it, all of the little cheat codes that Foundry has, it allows you to do extremely powerful things when you do testing and just overall development. So definitely would recommend using that. The other interesting question, because we haven't really talked about it, is the future staking. So we are implementing some form of staking in the future. And what that means is when we do release onto mainnet, we'll have the Dro token, and you will be able to stake that token to gain rewards from the overall community pot. So all of the fees that we will introduce when you want to deploy or update your traps, that will go into a kind of a big general pot that you as a staker will receive a portion of those fees as well. So that's the whole staking aspect. The staking narrative is you're going to be receiving protocol fees from the Drosera protocol in general. And as a staker, you'll be receiving some of those fees.
Yep. Um, any any thoughts, John, on some of these pieces, some of the core components? Perhaps anything that isn't there's something that would be helpful for somebody to understand um, when thinking about like what do they have on their computer or how do they interact with any of this stuff?
I think for right now, when we have our uh, intro directory in the workshop, so you can see that it's basically set up as how your Drosera framework should look. So you have your Foundry.toml, which will just allow you to compile, your Drosera.toml, which will allow you to interact with Drosera in general. So this is where you're going to basically have the brain of Drosera live in this toml. So you'll have the Ethereum RPCs. That's what you'll be interacting with. The Drosera RPC is kind of the relay between the operators and all the other operators, and then you have the Drosera address. So the Drosera protocol itself has one entry point, and we designed it this way to make it easier for you guys to start interacting with it without having to know a million different contract addresses to interact with a million different contracts. We've set up the whole pattern. If anybody's familiar, it's called Diamond Proxy Pattern. So it allows us to have one entry point that does everything. So it's all around through one contract and point. So you only have to memorize or just look at one contract address, and that will be the Drosera address. So when you see that, that just means it's the entry point to the entire protocol. And then down here is just the individual traps. So you can have multiple traps if you want to. In the future, we will allow multiple traps. And you can see that you can name it anything you want. So you have the traps, and then you can call it traps, whatever you want. So in this case, it's just called my trap, but you could call it something very specific to whatever you're doing. So if it's, say it's trading, you could do traps.my trading trap or something like that. It doesn't have to be specific to being called my trap. It could be called anything you want. In the future workshops this week, we'll go over what all of these different things mean. So we will change the path to your compiled contract, your response contract. We'll kind of dive into what that means and what you would put here, your response function, and some of the other keys that are in here as well. We'll go over them more in depth. But overall, it is very straightforward. All you're doing is collecting data on the blockchain in the collect function, so no matter what it is, and then reviewing that data, so going through the data itself, and then checking if certain things match criteria that you're looking for. And if they do, then should return true. And if it doesn't, then it should respond false and nothing happens. So it's basically an overall automation protocol. So we do very specific things for security, but you can look at it as literally being automation for anything. If it's gaming, this is why we developed the chess game. If it's trading, this is why we have the example for trading swaps. And then any other future things that you can think of that would need any type of automation, you can use traps to power anything. And Boba talked about this before, but it gives you a extra bandwidth for your smart contracts because these traps are all simulated off the blockchain. So you can make these traps far more computationally heavy than you would normally do if you just deployed on the blockchain because it doesn't cost you any gas. So you can get really, really crazy. And we will open source the chess repo eventually. So you guys can look at all of the crazy computation that it takes to actually go through the logic of chess. And you'll see that all of this is just running in the trap. So it doesn't cost any gas fees. And this is the powerful thing that you guys can now create these protocols with all of this crazy compute in Solidity, and you can write everything in Solidity and not have to worry about gas, which is coming from being a smart contract engineer and knowing that you have to be very specific on how things work on the blockchain because you don't want to spend too much gas. So you have to be very efficient in your Solidity. You can now be a little bit more sloppy, I could say, or just know that you could create really very intricate things without worrying about gas fees. So that's also very important when we go down into like when you start building your traps, don't worry about gas fees because it's all simulated off chain. You just have now extra bandwidth, all this automation bandwidth that is theoretically free for the most part without having the Ethereum fees.
Yeah, and that's like a really big part to understand is this diagram showing like the nodes themselves and having that trap contract in that node. You know, it's running outside of Ethereum, and because it's running outside of Ethereum, it means that this trap execution is gasless, right? Normally, when a smart contract it gets interacted with, that transaction gets included in a block, and normally that transaction has like some amount of gas fees associated with it. But with Drosera and these traps, because they're ran off chain, they're gasless and they're constantly running. Every block this smart contract is running, and you don't need to pay a transaction fee for its execution every block. If you were to try to execute a contract function on Ethereum today, every single block, you would run out of money really, really quickly, right? And it would also be very difficult to have your transaction execute every single block. But because this is off-chain and it's a lot more lightweight, we kind of have a lot more flexibility with how this computation is done, how these traps are executed. Yeah, so I feel like that is an important aspect to kind of understand. It does make it a little different in understanding how smart contracts work with Drosera compared to Ethereum, I suppose.
Yeah, there's another good question. What happens if we don't apply Drosera and then the node starts producing green? Not have a trap created yet, it will then create that trap and deploy it for you, that trap config. If you already have it and you update something, you want to apply those updates. So if you already have a trap out there and it's living and you don't hit and you change something and you don't hit apply, it's going to continue to do that same thing it was doing before. If you then hit apply, it will then update with those changes. So say you want to change the response contract address. So you want it to respond to some other address. So you change that and then you hit apply to update, and then that updates those changes on the blockchain. So if you don't hit anything and you're still getting green blocks, it could be possible because you're just running on the old version of your trap that you had before. So that's why you need to apply after you make any changes in your Drosera.toml. Make those changes and then do a Drosera apply. That will push those changes to the blockchain. And now those operators will start picking up what that new, say in this case, the response contract is. It will then, if say the response should respond as true, it will then respond to that new contract address.
Yeah, in order to actually get your trap changes, from your computer to the operator, you need to actually do Drosera apply. You actually have to deploy this kind of trap update by using Drosera apply. Apply is a specific keyword that's used kind of to substitute create or update, because apply will create a trap if you don't have one already, but it will also update a trap if you've already created one. So apply just means whatever I currently have on my computer, I want that to be out on the network. It's just kind of turn what I currently have into what will be running, right? And I've seen some confusion with that. People trying to understand, how do I update a trap or how do I create one? Really, you just want to use the Drosera apply command to do both of those things. The dev docs will also kind of show this and explain how apply works, what exactly does it do in detail. But again, those are going to be things that we're going to cover in the next workshop. Really, this workshop, the whole point was just to get people's feet wet, provide them like a basis for understanding what a trap is, what are the core pieces to think about when I'm kind of trying to build a trap, and really to show how simple it is to go and create these things. You really just need to have the Drosera CLI installed, and then you have to have these two files. Is all you really need. Obviously, in order to get your trap to run, you need to have an operator that is running the trap, but that's kind of like a second step. It's best to kind of start with, like, can I even deploy a trap first? Once you get past that step, then you can figure out, how can I run this operator? Or how do I run this trap with an operator, with a node? One thing that you guys should know too is that if you're doing this testing, you create a trap, you want to run a node that is running that trap, you can run that Drosera node locally. In order to do some type of testing to see, does this operator pick up the trap? You don't need to have anything special in regards to like running it on a VPS and like having a lot of the stuff set up. You can do local testing, with a node on your computer. That's what the Drosera team does as well. If we're testing some traps, we'll just spin up a node locally and see that it picks up the trap and it's running, and we try to mess with the trap logic to get the trap to trigger. So for these workshops, that may be the easiest way for you guys to do testing, is just to run the Drosera node locally. It's super lightweight, like it's not going to use like a ton of your RAM or anything like that. So, this is just a really easy way for you guys to play with this stuff. You don't have to worry about any of the hosting pieces of like having to go run it on some type of other platform or some other VPS. This should just make your lives a little easier when you're just kind of like messing around with the technology. So it's good to keep that in mind.
Yeah,
Yes.
and
So somebody said in chat, local operator is best. Yes. Local operator is
yeah,
best.
and
Yeah.
even before that, guys, I would suggest writing tests for your trap. So there was a question for us testers, is there any difference if a trap triggers or not? You can do, before you even spin up an operator, go and write solidity tests against your trap. So you can do all of this, and you could basically mock out what an operator would do by just writing simple solidity tests that simulate the trap going off or not going off. And we have a ton of examples here in the examples repo of us writing these tests for actual exploits that happened. So they're like, say, the Euler exploit, or so any numerous other exploits that we have for examples. We write tests in Solidity that would then mock out what an operator would do. So it goes, it collects that data, it checks if it should respond all in the test, and it doesn't need to, we don't need to spin up an operator for any of that. So when you are testing anything, if you are testing against Husky, and you can actually do this on mainnet or any other thing as long as you fork the network, you can check and to see if your trap is set up correctly or how you want it to be set up, just by writing basic solidity tests. And we have tons of examples of what these tests should look like. So you don't have to actually spin up an operator even locally beforehand. But then after you write those tests, then go and spin up your operator locally and then go from there.
Yep. So the trap is the key to everything. Yeah, basically. It is the core piece. Yep. It's the main thing you should be thinking about when you think about Drosera is, this is like a new type of like smart contract. It's something that is like not passive, but it's active. Smart contracts on Ethereum are kind of passive things. They don't do anything until somebody interacts with it, right? Until somebody performs a transaction with their MetaMask, and it takes like an action on chain. With traps, there is no kind of concept of interacting with it with like MetaMask or anything like that. It's constantly being interacted with, I suppose, from the operator. The operator is constantly running collection of data every block and performing some analysis. And so in this way, it's kind of like having this little module, this like smart contract module that is run off chain that you don't need to kind of interact with. It's like having a loop, like having a while loop in Solidity, kind of, right? It's like this ability for logic to constantly be running, and I don't need to have some type of off-chain thing that is doing this stuff for me or taking action on my behalf. Okay. We only got a couple minutes, I think, left here, guys. I'm trying to see if there's any other questions for us to answer.
I mean, the main one I've seen a lot is, are we going to be anything outside of Ethereum-based chains? And that's still up in the air. I mean, we are going to research where we can go into, but right now it's EVM compatible. So you could theoretically run Drosera on any EVM chain, L1, L2.
Yep. We've done some testing and seen some good results. on some other chains. So yeah, the idea is to just try and like use Ethereum as our home base and try to grow from here really. Already seeing lots of good traction. I love to see that we have so many people in this workshop. And I hope you guys kind of show up tomorrow for the next one. Just to close this thing out, this is the intro workshop, guys. So tomorrow the plan will be to go through workshop 1 and actually like run through some of those examples. It'd be another way for us to answer questions and help you guys understand how do I do this. I think it would be best if you guys also ran the exercises side by side with us as we're doing it, because that way we can answer questions in real time and help you guys get past the first workshop, which is simply to deploy a trap. Okay. Thanks for showing up though, guys. We appreciate it. I will answer any more questions in Discord if you guys have them, but I think we've kind of gone through just about everything plus more. And I will catch you guys later. Let us know if you have questions.
See you guys.
Okay. See everybody. Let's just stay trapping.